Digital communication system is the process of transmitting information from a source to a destination using digital signals. In this video, we will break down each block of the system step by step, so you can clearly understand how information is encoded, transmitted, and finally reconstructed at the receiver. This diagram illustrates the block diagram of a digital communication system, providing a complete overview of how information flows from the source to the destination. In the following section, we will explore each block in detail to understand how the system works step by step. First is the information input. In a digital communication system, this represents the original message or data that needs to be transmitted from one location to another. It can take different forms, such as voice, text, images, video, or sensor data. For example, it could be a human voice during a phone call, a photo sent via WhatsApp, a video stream on YouTube, or temperature data collected from a sensor. Next is the input transducer. This is a device that converts a real-world physical signal into an electrical signal that can be processed by the system. In other words, it acts as the interface between the physical world and the electronic communication system. For example, a microphone converts sound, voice, into an electrical signal, while a camera converts light into an electrical signal. Next is the source encoder. Its main function is to convert the input signal into a digital form, meaning it represents the information using 0 and 1. At the same time, it reduces data size by removing unnecessary redundancy and compresses the information to make transmission more efficient. The process typically includes several steps: sampling the signal, quantizing the amplitude into discrete levels, encoding the result into binary bits, and finally compressing the data into a compact bit stream. For example, in a voice call, the speech signal is first sampled, then converted into digital values, and finally compressed into a stream of bits for transmission. Next is the channel encoder. The channel encoder is needed because, during transmission, the signal can be affected by noise, interference, and distortion. These effects can cause errors in the received data. To overcome this, the channel encoder adds extra check bits, redundancy, to the original data. These additional bits do not carry new information, but they help protect the message during transmission. For example, in wireless communication, error-correcting bits are added before sending the signal. At the receiver side, these bits are used to detect and correct errors, ensuring the data is recovered accurately. Next is the digital modulator. The digital modulator converts digital bits into signals that are suitable for transmission through the communication channel. Its main function is to map binary data onto a carrier signal and prepare it for efficient and reliable transmission over the channel. Common modulation techniques include ASK, FSK, PSK, and QAM. Next is the channel. The channel is the medium that carries the signal from the transmitter to the receiver. There are two main types of channels: wired channels, such as coaxial cables and optical fiber, and wireless channels, such as air, radio waves, and satellite links. As the signal travels through the channel, it is affected by several impairments, including noise, interference, and attenuation, which is the gradual loss of signal strength over distance. Next is the digital demodulator. The digital demodulator is the receiver block that extracts the original digital bits from the received modulated signal. Its main functions are to receive the incoming signal from the channel, remove the carrier component, and recover the original digital data in the form of 0 and 1. To achieve this, it performs typical operations such as signal detection, synchronization, and down conversion, which removes the high-frequency carrier and brings the signal back to baseband. Next is the channel decoder. The channel decoder processes the received digital bits after demodulation. Its main functions are to detect errors in the received data, correct errors caused by noise in the channel, and remove the redundant bits that were added earlier by the channel encoder. This block is necessary because, during transmission, the signal may be corrupted by noise, interference, and distortion. The channel decoder helps recover the original data as accurately as possible. Next is the source decoder. The source decoder receives the decoded digital bit stream from the channel decoder and reconstructs the original information. Its main functions include decompressing the data, converting the digital bits back into an electrical signal, and reconstructing the original signal as closely as possible. The typical processes involved are decoding, decompression, and digital-to-analog conversion if required, depending on the system design. Continuing from the previous block, after the source decoder, we move to the output transducer. The output transducer converts the electrical signal from the source decoder into a physical form that can be perceived by humans. Its main function is to transform electrical signals into real-world outputs, such as sound, light, or images. For example, a speaker converts electrical signals into sound, a display screen converts them into images, and a printer converts them into printed text. Finally, we reach the last block, the information output. This is the final stage of the communication system, where the recovered information is delivered to the end user. Its main function is to present the received information in a usable and meaningful form, ensuring that the user can clearly understand or perceive the original message. And with this final step, the communication process is complete. From the original source all the way to the final user, we can now clearly see how information is transmitted, processed, and reconstructed in a digital communication system. I hope this video has helped you understand how a digital communication system works, from the source all the way to the final output. Thank you for watching, and I'll see you in the next video.